if normal on bead due to ring is at A is 0. The rate of change of speed at this instant. Draw the diagram, please draw the diagram. Draw the diagram. It will be this again very fundamental one. We are bringing the frictional force into the spring force into the picture. I'll give some better diagram. Yeah, you can see this one. We have a diameter. Then we have a spring. One end of spring is connected here. I'll just show only this one. And here is what a bead is there. There's a bead. This much is there. So there's a point O. This is A. This is B. It will make some angle theta that we don't know. Leave it here. We'll have one more reference line. This is the spring constant of K. Gravity free space. Spring elongated or compressed? What is the natural length of the spring? The bead is attached to a spring having natural length R. Natural length of the spring is R. I'll send the kids. Okay, this one. Small kids are, let them play. Let's not disturb, let them play. Okay, now so natural length of spring is R. What is the length OA? OA is given 6R by 5. And radius of the ring is R. So can we calculate what is the elongation in the spring? The elongation in the spring has to be calculated. The elongation of the spring should be equal to x should be equal to OA minus R. OA 6R by 5 R by 5. And how the spring force will act along the direction AO. So here spring force will show it. Simple. Then we don't know this theta. So then it's telling the speed of bead A if normal on bead due to ring at A is 0. There is some speed. The bead is having some speed. Then who will provide for it to move in a circular path? The normal direction is 0. I'll discuss now one more situation. Time being, there is no normal contact between the bead and the ring. This is the ring actually, and that black color one is a bead. Then kx cos theta should be equal to mv square L. How to? We have x. We know we have spring constant k. Then we have to calculate the v there. And what is the length? Okay, this is r, no? mv square r, sorry. It will rotate, this bead will move in a circular path about c, no? So therefore, what is the radius of curvature? That should be r. Now we don't know cos theta. How to bring cos theta?
Cos.
I think the circle, you know it. What is the length OA? OA is 6r by 5. So if you look at the circle, this will be 6r by 5. So 3r by 5, 3r by 5, this is r. Cos theta is needed. So cos theta equal to 3r by 5 by r. So 3 by 5. K, what is the elongation? R by 5. Cos theta 3 by 5 equal to m r v square. So what is v is equal to 3 k r square by 25 m. This will be the tangential speed of the bead A at this instant. Now is asking one more, the rate of change in speed at this instant. Rate of change of speed. What is rate of change of speed? Tangential acceleration is called as rate of change of speed in circular motion. Tangential acceleration is called as rate of change of speed. So how to get tangential acceleration? Kx sin theta will act on the bead. It will have tangential acceleration in this direction. It's a retardation, no? Actually, it is acting opposite to velocity. Or are you sure, sir? Or if you bring velocity like this, it will become acceleration. So in what direction velocity has not mentioned. Since the spring force will act in this direction, okay, I'm assuming it can be either way. If it is the acceleration is kx sin theta is opposite to velocity, it will be retarding tangential force. In the direction of velocity, it will be accelerating tangential force. That's all. Okay, now what is the tangential? MAT should be equal to kx sin theta. Kmx is r by 5, sin theta 4 by 5, 4 kr by 25 m. Getting this one? So spring force. See, who can provide centripetal force or all the thing? If the component of spring force is providing centripetal force, other component is providing tangential force. It can be anything, no, normal contact, tension, weight, friction, spring force. All these forces we know. So due to that, we are analyzing the circular motion. The problem is if there is a, I'll just discuss some cases very important for you. Some conditions are there which are essential for you to learn. The same how to get the normal reaction is something very important. Normal reaction in these cases, how to take it. Please, all of you, advance already twice they have asked, so there's all possibility of asking such very beautiful questions here. Okay, let me give the velocity v. Let there be a gravity also present. So due to gravity now, this is some general discussion. Okay, a good number of questions can be asked here. That is one of the questions. Let's have some discussion on this one. The weight mg will act. Let's get into the discussion now. There is a ring A. Some velocity is imparted to the ring A. So sorry, bead A. This ring is fixed. I will impart some velocity. How you normal contact will be there. It all depends upon the spring force. Now the spring is elongated here, so it will try to pull the ring towards the center. So therefore, if you look at the bead, if this is the ring, we have to learn how the forces are acting here. Okay, there's a part of the ring, and this is our bead, no? Some thick line will take it. No, how the ring will be in contact with this. The bead will be in contact with the ring in this way. Keychain, you'll be having the keychain, no? So when you look at that keychain, things will be off like this. So here, how the forces are acting: spring force. This is the force towards center. This and the weight mg will act here. How the normal contact by the ring on the bead should be radially outward. Should be radial. You should not show against kx or mg. It should be along the normal, no? This will be the common normal. Am I right? And if it is any given velocity, okay, give it here. Now, what is the equations you are going to write? Theta. Then how the equations will be? Kx cos theta. This angle we don't know. Let me write mg sine phi minus n. The equation. What about any tangential acceleration? Any tangential acceleration, it should be mg sine phi minus kx cos theta equal to met. Are you able to understand? If a spring is compressed, then the spring force will act here. All possibilities are there. So many possibilities are there. If such that the spring is compressed, then the spring force will act here. Then there's a possibility that it may be either way. I'm just generalizing concept here. Keychain, so not understanding. Keychain, I think ring will be there, no? For keychain. And just put it to your finger and see that. It has become very...
Sir, kx sin phi. Kx cos sin theta, sir.
Kx, okay, this one. Okay, I wrote it, this one. Cos. Sin theta, yeah. No, let me take this ring one. Ring will be... When do situation like this will come? This is the center C. If the spring force, if the spring is compressed, the spring force will act here. Mg will act as usual. The normal contact now will act in this direction. So how come you are changing direction? So there's a spring. Spring is compressed. Here spring is elongated. Spring is elongated. Here what about spring? Compressed. Compressed means spring force I have to show in this way. Now look at the normal contact. Normal contact will be there. Again put velocity v0 and let it have a tangential acceleration. I think we have to be very careful now how the ring is in contact, how the bead is in contact with the ring. The normal contact will come. I think you take the keychain, ring will be there for a keychain, and put your finger, try to rotate it and see that how that ring on the keychain will come in contact with your finger. That's what I'm discussing. So this is not, I think, very new for you. What are the equations of motion we can write here again? Okay, this is as usual theta phi. Okay, how the equations of motion will be? We will provide now n plus mg cos phi minus kx cos theta equal to mv naught square L. What about the tangential acceleration? Mg sin phi plus kx sine theta equal to MET. If I release from rest, what is the problem? If I release from rest, if the ring is just released here, in that case, you should not equate anything, because you should not go for mv naught square. If you release from rest, no, okay, just put v naught 0, then solve like this. But there will be tangential acceleration. So when when do this v naught will come, mv naught square r, if the bead is given some velocity, then you have to write equation like this. If the bead is just released from rest, in the same problem, I just release from rest, no, then put v naught 0, then write this much of equation. But tangential acceleration will be there, the resultant forces. So the bead, how it comes in contact with the ring, I think matters a lot. You should have a good observation. So this is what, when spring is compressed, this is spring is elongated. So I think the spring force also matters. So we should take decision based on the conditions here.